Do you need to configure network adapters under Linux? Let's talk.
You're watching IT Pro TV.
Hello, welcome back to LPIC2. I am Zach and this is Don, and we're looking at the wonderful world of network adapters, aren't we?
That's right. You know, in Linux, a lot of times your network adapters are set up automatically, but as a Linux system engineer, you'll likely be expected to do static network configuration. So in this episode, we're going to learn about how that's done, some of the different ways that your network adapter might be configured, because unfortunately it is very different as you move from distro to distro. So we'll take a look at that. We'll see some of the commands that can make it a little bit easier to manage our network adapter and see how we can verify the network configuration, all right here in one action-packed episode.
Well, Don, how can we view our current network configuration?
So there's a handful of commands that are pretty consistent that you can count on to look at your network configuration. And probably, you know, one of the older commands that a lot of people rely on is the ifconfig command. Let me show that one to you here. I'm going to drop into my terminal. Actually, hang on, I might not be able to show it to you. ifconfig is an older command and it's being replaced by a new command I'll show in just a second. So let me see if ifconfig is even on here. It is not. So see how it's telling me I need to install nettools, which is a package of older utilities, and I can do that real quick. It's not a big deal. But once we have that package installed, we can run ifconfig and we get a summary of our interfaces. Now, the way ifconfig worked is that command would go and pull from your network configurations and try and build this up and show you what the network configuration was. Well, that works, but it's not the most efficient way of doing things. And as the Linux kernel evolved, they added new API interfaces so that you can actually just talk to the kernel, and the kernel will tell you the network configuration. It's already got it, and you know that's the configuration that's actually running right now. So ifconfig was replaced by another tool called IP. And the IP utility actually reaches into the kernel to get its information. So if I were to type IP space ADDR, that's going to show me my IP addressing information. And you'll see it's basically the same information we saw with ifconfig, just formatted a little bit different, and like the extra error counters and things are missing. There's other ways to pull that data. But here I can see the configuration of my adapters. I can do an IP route and see my routing information if I've got a default route in place or something else, and so I can learn about it. It's always important to see what your configuration currently is to find out whether or not you actually need to change it.
Well, is there anything that we should do before we start fiddling around and changing things?
Yeah, you know, if we're trying to set a static IP, then we're going to have to change things. That's just how it is. But if we're just trying to get our system working again, well, we're going to have an episode on network troubleshooting in a minute, but there are a few quick things you can try. For example, if you're using DHCP, maybe you just timed out reaching out to a DHCP server, so you can trigger DHCP to go and redo its job and get an address again. The way you would do that is by using DH client. So that's the DHCP client. You can do a sudo DH client -R, and that will release, oh, I have to spell it right. There we go. Sudo DH client -R. That will release whatever IP address you're holding, and then you rerun sudo DH client by itself, and that'll try and reacquire an address. So sometimes that's all we need if we're just trying to get on and get going. Or you might need to restart your entire networking stack, especially if you've made a bunch of changes. The changes might not take effect right away. So you can restart that networking stack. On a sysvinit system, you would type, let's see, you would do sudo service network restart, like that. And that would restart the networking stack. I'm on a systemd system though, so that doesn't work. So this would be something I would do on like CentOS 6 or some older system. On a newer system, we would do sudo systemctl restart, and then most systemd systems are using what's called the network manager. So I would say sudo systemctl restart network-manager. When you run that, that's going to cause it to reload the configuration and hopefully sort your problem out, right? So it may be as simple as doing one of those things, and I don't have to go in and change anything at all.
Well, where are the network interface configurations stored, though?
All right, so if we're just doing automatic configurations, they're probably not stored anywhere, right? It's just automatically configuring, and that's that. But if we're going to do a static assignment, or if a static assignment's already in place, then there's going to be configuration files. Unfortunately, I can't just tell you, here's the one place you go, because there's actually several different places it could be. So let me give you a few examples. If I were on a Red Hat based system, so CentOS, RHEL, Fedora, even SUSE, if I go over to a Red Hat system, Where I'll find those the configuration files is in /etc/sysconfig/network-scripts. So that folder right there, if I go into that folder and take a look, what I should see are files representing my interfaces. If I run IP-ADDR, I can see I've got a interface right here, which is called ENS160, and it's got the IP address 10.0.222.52. And so looking in that folder, I see ifcfg-ENS160. So that is my configuration. And if I were to edit that, so let me do a sudo edit of that file. And I look in here, here it is. Here's the configuration file that's defining this adapter. And I can see pretty clearly what I need to do. IP-ADDR equals 10.0.222.52. If I want to change that, I just go and I replace it. And the gateway, DNS settings, and so on, they're all easily defined right there inside of this configuration file. So on a Red Hat-based system, that's where they'll be stored. All right. On a Debian system, it's a little bit different. Instead of, oops, let me get out of this. Instead of /etc/sysconfig, they're actually tucked away in a different spot. It's still in /etc. It would be /etc/sys. Let's see, it would be, I got to remember, /etc/network. There we go. /etc/network/interfaces. That's where it is on a Debian system, so I'm not going to have that on this one. So let me just try and get to it. Yeah, so I don't even have that directory present, but it would have the text files there. And the text files are a slightly different format. Look at the show notes. I'll put examples of both sets of configuration files. But you just edit those files and change them. Then the next time the network reloads, it's going to read those, process them, and now you've got those changes in place. So different places to go. It can be a little bit challenging. Making it even harder are automatic services like the Network Manager or NetPlan. The newest versions of Ubuntu use NetPlan. Let me show you on this Ubuntu server that I've got. If I go into /etc/netplan and take a look in there, I've got this 00 installer file. Let's look at that file. And looking inside of it, I've got an Ethernet network, an interface, ENS32. Here's the IP address assigned to it, the gateway, and so on. NetPlan is a service that's designed to do cloud deployments and pull IPs from different locations. So this is a whole separate service that's overriding the network configuration. So when we work on a Linux server, we've got to find out, is it just using regular configuration scripts to configure the adapter? Or does it have NetPlan? Does it have the network manager? It's really confusing, so we've got to figure that out before we can actually do the configuration.
Well, do the interface names mean something? What does ENS mean?
So we've seen, actually I guess we've only seen ENS, right? So I got ENS32 over here on my Red Hat system. I had, what did I have? ENS160, I got a virtual bridge, that doesn't count. Let me look on my laptop, what do I have here? See if I have anything really cool. Well, ENS33, all right, so these are boring. Well, when you look at these interface names, the names do mean something, all right? The first two characters are telling you what type of adapter it is. So when I see EN, that's an Ethernet network adapter, and that means a physical network jack. On the side of my laptop, I've got a copper RJ45 jack. That's going to be an Ethernet adapter, so it'll have an EN. If you see a WL, that's a wireless LAN. So I've got a wireless adapter. Those will show WL followed by something. Or if you see WW, WW means it's a cellular wireless card. So if you've got like a 5G card and you're on a cell network with it, it'll show as WW. All right. So those are the first two letters. Then the third letter is indicating the type of slot that it's in. Okay. So it might be on board, in other words, built into the motherboard. And so you would see ENO if it was an Ethernet adapter soldered onto the motherboard. Or if it was in a PCI slot, like a PCIe slot, it would show as ENP. Or like mine, where it says ENS, the S means it's a hot plug slot, right? Hot plug slot usually refers to USB. USB is the hot plug most people use, but there are some PCI slots that are hot plug, and so it'll show as ENS in that case as well. So those are kind of what those names mean. UDEV is what assigns those. We don't normally change them. The only annoying part are the numbers at the end. When you're dealing with physical adapters, it'll normally start with a 0, so they're nice and small. But when you're on a virtual machine, like I am with my my Ubuntu system here, you'll see some of the interface numbers ENS32. That doesn't mean I've got 32 network adapters. It just skipped to a high number to make sure it didn't conflict with anything physical. And on the Red Hat side, I had ENS 160. Like, I don't have 160. It just jumped that high to avoid conflict.
Well, what about global settings like DNS servers?
Okay, so what I've shown so far has really been focused on individual adapter interfaces, right? So if I've got multiple interfaces, I'll have multiple configuration files, and that's where we'll have to set those. But I might just want to set DNS servers one time, and that applies to my whole system. Those are global settings, and those get set different places. Now, you might set them on the adapter. In fact, on my Red Hat box, I did just that. So let me bring up the configuration here again. And you'll see on this interface, I've got DNS servers defined, right? Or if I was using DHCP, I'd automatically be getting those, right? So for DHCP, up here where it says boot proto equals none, we would say boot proto equals auto, and that would tell, or DHCP, and that would tell it go and use DHCP to get that address, and it would get DNS servers at that time. So the interfaces can have those settings. But if we want to set it globally, we're going to have to rely on something else, and it's going to depend on our system where that setting is going to come from. So we're going to have an episode on troubleshooting name lookups because this is a challenge for a lot of people. But on older systems, what you'll find is inside of /etc, you'll find a file called resolve.conf. And so if I look, I should have it right there, resolve.conf. Okay. And if I look inside of that file, what I see for mine is I have two name servers. Name server 8.8.8.8, just like I saw on the interface. In fact, that's probably where it came from, right? But I didn't put them here. The very first line tells me generated by network manager. I have the network manager running on this system, and it looked at the interfaces, figured out what the best candidate was for the name server, and put it in here. If I edit this file, it's going to get overwritten the next time the network manager processes configurations. So because I have network manager in place, I can't edit this file. But on an older system, this file is where I would actually define those name servers, and they would be globally defined. All right. Now, I said I'm running the network manager, which I am, but I'm also on a systemd system. And systemd may or may not, depending on your distro, be running a service called systemd resolved. And resolved is designed to handle name resolution for your system. So I can clearly see on my interface and right here that I've got 8.8.8.8 set as my DNS server, right? That's Google's DNS servers. But if I do a quick test, I'll just do nslookup www.google.com. Okay, so I get an answer back, and oh, actually it did use that server. It did use 8.8.8.8. Let me show you an example. Let me jump to maybe Ubuntu and see if it does different. We'll look up google.com here. And there we go. That's what I wanted. Look at the DNS server that I've got over here. 127.0.0.53. What the heck is that? Well, 127.0.0.1 is the loopback. That's yourself. But a lot of people don't realize that actually 127.anything is the loopback, the entire 127 range. And so here, 127.0.0.53, that 53 is a hint that this is DNS. If you're running systemd resolved acts as a proxy. It sits in between you and your DNS servers. So your name lookups actually go to resolved, and then it goes out to look at the DNS servers out there on the internet. So if I want to change who my DNS servers are, I'm actually going to have to change that by using resolved, not by editing an interface script, not by editing /etc/resolve.conf. In fact, on this system, let me take a look at resolve.conf. And right here, I see a giant warning in the resolve.conf file. All this stuff up here at the top is a big warning. This file is managed by systemd resolved, and it just goes on to tell you, like, you really shouldn't edit this file because it gets overwritten all the time. And then the name server down here is just me anyway, right? So so this is kind of telling me that our settings are being set somewhere else. It kind of reminds me of, remember Super Mario Brothers? Mm-hmm. Whenever you beat a level, it wasn't actually the princess. She would say, oh, the princess is in another castle.
Exactly.
That's how resolved is, right? So the princess is in another castle. If you want to mess around with this and kind of see what it's actually using, you can run resolve ctl status. and that'll show you what you're actually set up for. And so I can see I've got DNSSEC, and as I move down, here's my current DNS server 8.8.8.8. So it is actually using the server I want. It's just sitting in between. And so if we want to manipulate that, we have to go into /etc/resolve. Ooh, do I not have it? I may not have this one. So let me go into /etc. Do I have a resolve conf folder? I might have to make it. If it doesn't exist, it does not, so I'll have to make it myself. So if it doesn't exist, you can make the folder yourself, /etc, and I'll do sudo mkdir -p. -p is parents, so I'm going to create subfolders, and it'll create the parent folders for me. It's going to be /etc/resolve conf/resolve conf.d / actually that's the folder I need, so I'll make that, and I'll get into it, and then you just drop a folder in here. I'll do sudo edit called head. And this is going to be the head of the configuration for Resolve D. And you can drop in settings in here, like you can say name server 4.2.2.1, like that. And so now when Resolve D runs, it's going to see that and incorporate that. So I'm now kind of overriding that configuration. Otherwise, it's going to look to the interfaces and pull it. That's where it got the values that it already had. So just know that global settings like DNS are even harder than network interfaces because we have to figure out where it's being set from, and there's so many different places.
But what about the host name? I didn't see that setting anywhere.
Oh yeah. So the host name. So like if you look at mine, mine's called Ubuntu-server, right? That's my host name. On a systemd system, it's not set from a configuration file. It's actually set by a service, and you can run hostname CTL to be able to see what your current static host name is. There it is, right there. If I want to change what that host name is, I can just use hostname CTL to do it. So I would say sudo hostname CTL set -hostname followed by whatever I wanted that name to be. So, maybe I want to call this one Don's -server. All right. Now, when you run it, don't expect to see that change right away. All right. Because when you log in and you go to a bash shell, it creates that prompt at login time. So I'll have to exit out and then reconnect before I actually see that change. But now I can see it right there. It's now called Don's server. So hostname CTL is how we would modify that one.
And what about the network manager? Now, is that easier than using the other tools?
So I'll have to say yes and no on that one, right? So the network
I love
manager,
those answers.
it's harder to use, right? It's harder than editing a text file. However, the network manager sorts everything on the back end for you. So if you've got a Debian system or a Red Hat system, if you've got systemd or sysvinit, if you use the network manager, it figures everything out and it just takes care of it. And so the network manager has kind of become the de facto way of configuring things. On Red Hat systems, it's installed by default. On Debian systems, you may have to install it yourself. It depends on the installation media you use. Some Ubuntu systems have it already. But with the network manager, you have what's called the NMCLI, and you can run NMCLI status to get a list of what's going on the system. So looking at this Ubuntu box, it actually doesn't have it. Let me jump over to my Red Hat one. And here I'll do NMCLI status. And, it doesn't know my status command. Oh, shoot, I need to do device status. There we go. NMCLI device status. There. So I can see my network adapters. If they're green, that means Network Manager knows about them. They're managed. I've got a couple others that aren't being touched by Network Manager, so I see them. But I can go in and I can do configurations without having to hunt down files. I can, for example, like if I wanted to set DNS, I could do sudo NMCLI connection, edit, and then the name of the connection that I want to edit. So I'm going to edit ENS 160. So I'll edit that adapter. Okay. I don't know where the configuration file is. I don't care where the configuration file is. Network Manager will figure it out. And then once I'm in here, I can make changes. I can say set IPv4.DNS, and I'll set it to 4.2.2.1. So I'll change that to something different. Again, I don't know which system is handling DNS for me. I'll let Network Manager sort it out. And when I'm done, I can do a save, and I can say save temporary like that, which is going to save it to the running configuration. But if something goes wrong, I can just reboot and it goes back to normal. Or I can do a save persistent, which will actually save it to disk. There it is. Now that change is permanent, and I can quit out, and I'm good to go. So how did I know to type set IPv4.DNS? Well, I had that one memorized, right? Or I end up going to the documentation to pull it up. So that makes Network Manager a little harder to use, But the fact that I don't have to figure out where all the various configuration files are, that makes it a winner. So sometimes it's easier, sometimes it's harder. That's the long answer.
Fantastic. Well, thank you for the answer. Configuring physical adapters, and anything else you'd like to add, Don?
These things change all the time. Like NetPlan was only recently rolled out in Ubuntu, so stay up to date on that. On the exam, they're going to focus on the Debian and Red Hat configuration files mostly, and you may see Network Manager creep up on there. I've not heard of anyone seeing NetPlan on the exam yet, so kind of focus on the ones that they're going to be testing you on. But in real life land, you're going to encounter them all. So be aware that you may have to hunt around a bit to find configurations.
Thank you, Don. Another great episode of LPIC 2. And thank you for joining us for this great episode. Make sure you watch every episode of LPIC 2. You're going to be very glad you did. We'll see you again next time. Bye-bye.
Thank you for watching IT Pro TV.
Wireless adapters don't configure themselves, do they? Join us.
You're watching IT Pro TV.
Hello, welcome back to LPIC 2. I'm Zach, and who are you again?
I'm Don.
That's Don. We're talking about all things LPIC 2 and configuring wireless adapters. That's where we are right this minute. I don't think that would be a big lift, or is it?
No, it's not too bad, but wireless adapters have kind of become the de facto standard for laptops and even a lot of desktops for getting connected to networks. In previous episodes, we've seen configuring wired adapters, but in this episode, we're going to look at wireless specifically and some of the differences, because we have wireless encryption standards like WPA and WEP that we have to set up, passkeys. We have to be able to find the wireless network. And so these are extra steps involved in configuring a wireless adapter. We'll knock all those out right here in this episode, and at the end of it, you'll be ready to configure your wireless adapter.
So you just touched on that. So how does configuring a wireless adapter differ from configuring the wired?
So it kind of comes down to the OSI model. So if you've done like Network Plus or any kind of networking studies, you've learned about the OSI model and how network communications are broken up into layers. And at layer 1, you have the physical layer, which is usually your adapter. And at layer 2, you have your data link layer that allows devices to find each other. And then at layer 3, you have your network layer. And that's where you start to get into IP addressing and then transport it and so on. All of that is stacked above, right? Well, a wired versus a wireless adapter, for the most part, is all way down at layer 1. Layer 2 through layer 7 are all the same. And that means things like assigning an IP address, a default gateway, DNS servers, turning the adapter on, all that is the same between the two. So if you've already watched our episode on configuring a network adapter, you've already seen 95% of what it takes to configure a wireless adapter. The only thing that's going to be different is some of the security mechanisms and then how we get connected. With a wired adapter, I just plug a cable in, right? I plug it in and now the system knows it's on a network and then it talks. But with wireless, the radio looks out for wireless signals. It looks out for networks that are advertising their name. Their name is called an SSID, or a service set identifier. So it's looking for that SSID, but it'll likely find more than one. And it doesn't know which one to pick. So we have to tell it which one to pick, which one is the right SSID. And then if that SSID has security on it, we've got to tell it what security to use, what encryption, what authentication, is there a passkey, is there a certificate? We've got to give it that information too. But then once it has that, it's able to connect to the SSID, and from there on, it's exactly like a wired adapter. So we really just have to jump through that little bit to get connected, and then we're in business.
So what tools do we use to configure Wi-Fi?
We can use some of the standard tools that we've already used. Honestly, if you're on a desktop, the easiest way to configure a wireless adapter is to just use the network manager that's likely up in your taskbar. So for example, on my machine, if we take a look up at the top right of my desktop, I've got a little network symbol up there, okay? And if I click on that, I can see I have a wired connection, which is what I'm actually using, so that's the one my laptop is tied to, but I've got a Wi-Fi adapter that is not connected, right? And I could click on that and go through and select a network and turn it on and do all that and then be up and running. So on a desktop, it's easy to get this configured, right? You don't need to watch a whole episode on that. But on the exam, they want you to know how to do it from the command line. Because if this is a server, right, then you would want to be able to configure it that way. You wouldn't have a GUI. Now, you might ask yourself, wait a minute, if I have a server, why would I use wireless? Why wouldn't I use wired, right? And the answer is you're right. On a server, you typically want a wired connection when possible. But wireless connections are really handy if you're doing like a Internet of Things type deployment, if you're sticking a server somewhere remote for doing like monitoring and reporting. I installed a little Linux server years ago in the top of it was a cement quarry where they would actually make cement. And they had this big tower, and we had to monitor emissions up at the top of the tower. So the air quality up there. And running a cable all the way up this tower would have been a lot of work. We were able to just stick a little box up there with a wireless card, and it was able to communicate down via Wi-Fi, and that worked out great. So those are solutions where Wi-Fi comes in really handy, but now you've got to configure it from the command line. Well, fortunately, most Linux distros use the network manager, and the network manager CLI is able to do wireless networks just fine. And you'll find that it's pretty easy. So for example, if I'm dealing with, I mentioned like the OSI model, right? And how layer 2 and above are pretty much the same for wireless networks as they are wired. You know, on a wired adapter, if I just wanted to see if it was present, a lot of times I would just run IP ADDR, show me my IP addresses, right? And that would show me my physical Ethernet adapter right there. And if I look down here at the bottom, I can see I have a wireless adapter as well. My physical network adapter starts with EN, so it's an Ethernet adapter. My wireless adapter starts with WL, wireless LAN, right? So I know it's a wireless LAN adapter. If it was WW, that's a wireless WAN. That would be like a cell card. But WL, that's going to be just some kind of 802.11 variant of wireless card. And then I can see the identifier that's stuck on it. Now notice mine has an X, which means it's external. I've actually got a USB wireless card stuck on here. So that's what it's picking up. And that means it gave it a random ID, which is this obnoxiously long thing. If you have an internal wireless adapter, it won't show up that way. It'll usually be WLS or WLC, one or the other, followed by 0 or 1, you know, something a lot easier to read than this craziness that I have. But notice how it says no carrier, right? It's not connected. So I can see it just using the standard tool, but I know I've got a little more work to do. And the same thing with the network manager. I can do sudo nmcli connection show to see the connections that I've got. And I can see my wired connection right there. I don't have a wireless connection. So obviously I'm going to need to create one. If I look at my devices, if I do sudo nmcli device status, I can see my devices, and right there I can see my Ethernet adapter is connected, but my wireless one is disconnected and it doesn't have a connection created around it. So it's just waiting to be configured. But the nmcli is able to see that. But it can even go a little bit further. I can say sudo nmcli dev, which is short for device, Wi-Fi list. And that says, take any of my wireless adapters, which I've only got one, so that's easy, and then show me any wireless network that it can find. And so it's scanning right now. It's checking that the air around me shimmers. Not really, can't see it. But then it's going to spit out a list of the wireless networks that it finds. And it's a pretty cool output because you can kind of see the strength of each network. You can see what security they're using. We've got a bunch of WPA2 stuff here. I can see what channel they're on. These are the networks that are available. So this is all using the nmcli, which we've seen in other episodes.
So let's say our adapter isn't automatically configured. So how do we manually attach to a Wi-Fi network?
Okay, well, we're going to need a few pieces of information, and actually I've already seen them all here on the screen, so this is going to be helpful. First off, I need my adapter name, which mine is obnoxiously long, so you know, I'll copy and paste that in just a moment. And then we need to know what wireless network we're going to connect to. So looking at the list here, I've got IT Pro TV Guest. That's the one I'm going to connect to, all right? So I need to know that, and then I need to know the security information for it. So looking over here, I can see it's WPA2. WPA2 has two modes. It's got a pre-shared key mode where I just need a password, and it's got an enterprise mode where I would need a certificate. So I need to know that, right? But once I've got that information, now I have everything I need to go in and actually get connected. So to get connected, the first thing I need to do is create a connection, right? When I did my device status, I could see the device here, and I'm actually just running that so that I can copy the name so I don't have to type it. So I've got that. But when I did a connection list, right? So when I pulled up the connection show, I don't have a connection from my wireless network. I need to create one. So to create one, we say sudo nmcli con, which is short for connection, add con-name, and I'm going to give it a name. Now, I love that I can give it a name because I don't want to use this long, obnoxious thing. So I'm going to give it a shorter name. I'm going to call it WLX0. So that's a lot shorter. And then I can tell it the interface name, IF name, and that's where I'll paste in what I just copied. So there's that big, long, dumb name. And then I can say type Wi-Fi, so it will know that this is a Wi-Fi connection. And then I will tell it the SSID, which is going to be IT Pro TV-guest. That's the network I want to connect to. All right. So that's going to create the connection. I should see successfully added. And now when I pull up sudo nmcli connection show, I can see I've got that new connection right there. Now it's not actually connected yet, but it knows what I want to do. It knows I want to use this wireless adapter, and it knows I want to connect to IT Pro TV guest. So it's got that. What I need to tell it next is the authentication piece. So I'll tell it sudo nmcli con modify WLX0, much easier. So I'm modifying that connection, and then I'll say wi-fi-sec.key-mgmt, and here's where I tell it whether I'm running in WPA Enterprise or WPA with a pre-shared key, which is what I'm doing. So I'll say WPA-PSK, so it knows that I'm using a pre-shared key. Then I need to give it the key. So I'm going to, oh, you actually see I got a little warning up on my screen. Authentication required. Passwords or encrypted keys are required to access the wireless network IT Pro TV guest. So I just told it that I need a password, and now it's oddly enough asking for what that password is. So I'm going to just modify that command that I just ran a little bit. So basically the same command, sudo nmcli con modify WLX0 wi-fi-sec.psk, and I'll follow that up with the password. So here, we'll just punch that password in. This is our public network that we share, Zach, so I don't mind typing it in here. So I'll punch that one in. So now it's got the password for that wireless network. I defined the connection. I told it to use WPA with a pre-shared key, and then I gave it the key. The last thing I need to do, turn the adapter on. Well, the adapter's technically already on, right? I've been scanning. I need to turn the connection on. So I'll say sudo nmcli con up WLX0. That's going to bring that connection up and online. Now, it may pause for a moment while it reaches out, connects to the network, authenticates, and runs its little test. But when it's done, I'll be on the wireless network, and everything else from that point on is exactly like a wired adapter. If I want to change the IP address, if I want to configure UFW or a firewall of some sort, it's just WLX0 is the name of that connection, and that's what I would use for any of those things. I can see connection successfully activated, and if I do a IP ADDR now and take a look, here's that wireless adapter. But instead of saying that it was offline, right, no carrier, now it says it's broadcast, multicast, it's up, it's running, and I can see I got a DHCP address right there. I'm on the network, and I'm ready to communicate.
Congratulations on that, sir. But now that the connection is up, do we configure it like any other network connection?
Yeah, that's it, right?
Yeah.
So from here on, we're free on that. Like that's where like the differences between wired and wireless end. Mm-hmm. And so now it's all the same. In fact, if it weren't for the different icons, like here, I'll just go up to my network manager here at the top right of my screen. If I click on that and pull it down here, I've got the wired connection, and it shows IT Pro TV guest. So I can disconnect if I want to disconnect or whatever. But from the command line, everything else is done the same. So, if I have net plan configured or other things to assign an IP address, I would just go and modify those. I'm using Network Manager here, so I'd make modifications there, but it's all basically treated the same.
Configuring wireless adapters made easy, and I know you have something else you'd like to say.
Just to wrap this one up, the key things to remember here, wireless adapters are a little bit harder than wired adapters just because there's information we have to find. But fortunately, NMCLI was able to turn all that up, right? We needed to get the name of our adapter, which I got with IP ADDR. We needed to get the list of wireless networks that were available, which I used NMCLI for. And then once we had that combined with our security configuration, we just went in and set that up by creating a new connection in the network manager. So really easy to do. It's a lot of commands to memorize, though, and you will want to have those memorized for the exam. In real life land, you can kind of Google them real quick and cheat a bit. On the test, they expect you to know them.
Mm-hmm. Important stuff, and thank you so much for all that information. And thank you for joining us for LPIC 2. You know there's more in store. We'll see you next time. Bye-bye.
Thank you for watching IT Pro TV.
Are you having trouble with your network connectivity in Linux? Let's talk about it.
You're watching IT Pro TV.
Hello, welcome back to LPIC2. I'm Zach, this is Don. So I'm having trouble. Troubleshooting connectivity.
Well, the important thing is that you seek help.
I know, it's true.
And that's what we're going
Have
to
to
do right
admit it
here
first.
in this episode. Yes, we're going to admit that we've got a problem. Our problem is networking, and how are we going to solve it?
Yes.
So we'll take a look at several utilities that we can use to diagnose networking issues to try and narrow down where the actual problem is so that we can repair it and get back online, because networking is so important for most users.
Well, where do you start when we're dealing with network connectivity? Where are we starting with this troubleshooting?
All right, so it's tempting when you have a network issue to just dive right in and start trying to fix the problem, right? But it's oftentimes worthwhile, especially on servers, to take a deep breath and establish a scope. Try and find where the actual problem is, how much is affected, because there's plenty of times where the problem is right here on our own machine, but there's also plenty of times where the problem is outside of our machine, not actually our fault, right? My computer might not be able to connect to the internet, and it turns out that my ISP is having an outage, or there's a bad BGP route out there on the internet, not even in my building, just completely separate from me, there's a problem. So we need to figure out what that scope is. And there's a couple of utilities that really help with that. The most common one, the one that most people deal with, is ping. Ping has been around forever, and we can utilize that ping utility to be able to figure out where the problem is. So you do have a bit of a choice on how you want to handle this. There's two schools of thought. There's one school of thought that says, start with the thing furthest away from you, and then come back step by step, getting closer and closer to your laptop or server or whatever to figure out where the problem is. Or there's the other way around. Start with your device and move out. And that's what I normally do. I normally start with my device and move out. But either way works. It's up to you. But the point is you just don't want to miss any steps, right? So with ping and that in mind, I can start to try and figure out where my problem is. So the first step, now I'll show you here in my terminal. The first step is I'll just try and ping myself. Now there's two different ways that you can ping yourself. One is pinging via the loopback, and one is by pinging by your actual IP address. Well, pinging via loopback is actually really useful because it tests the network software stack. Is the software, the TCP/IP stack, actually working properly without bringing hardware into the mix? When you ping your actual IP address, your IP address is attached to an interface. Like if I run IP ADDR, I can see the interfaces, and so the IP is tied to that physical hardware. If I ping that IP, the hardware is getting involved. So I'll always start by just pinging my loopback. For IPv4, I would type ping 127.0.0.1 like that, and that would ping me. And if I get a response back, I know the software is working. If I'm doing IPv6, I just change that a little bit. Instead of regular ping, I would do a ping 6, and then ::1. That's the loopback in IPv6, and now it's going to start pinging me there. All right. Now, on many distros, the ping utility is smart enough to know to switch to IPv6, so I might not actually need to do ping 6, but if you type it, it's a way to guarantee it's going to work. All right. Now I know my software is good, I move out to the next step, the hardware, to my network adapter. So my network adapter is 10.0.222.50, so I'm going to try and ping that, and I'm getting a response there. So now I know my hardware is most likely working, okay? I'm just trying to communicate to it. From there, I can start to test out even further. All right, well, can I get to other hosts on my network? So I'm .50, can I ping .51? Okay, I can. Now, if I couldn't ping .51, maybe I've got an incorrect subnet mask. Maybe I've got some configuration here that's making it where I can't find these other people. Maybe I'm got unidirectional communication on the switch, things like that. Those are the problems I have to start thinking about. Assuming that works, though, the next step is hitting my router. Can I get to the router? And on my network, that is going to be 10.0.0.2, and can I get there? All right. If I can't get there, again, I've probably got some physical connectivity issue between me and the router on my own network. Can I get to the next network in line? Well, the next network in line would just be somebody outside, right? So I could pick somebody out on the internet and reach all the way out there. Now I'm going through the router or firewall to get there. So what you see is I'm getting further and further away from my computer. And with each step, it's helping me to try and figure out where that problem is. Now, I just did this all kind of one at a time. There are utilities that can speed this up. There's the old traceroute utility, which not every system has traceroute installed by default anymore. I could have just done a traceroute to 4.2.2.1, or even better with a host name. If you do a host name, like I'll do itpro.tv, now it's testing DNS as well, right? Is my DNS able to resolve? But see how it's going and grabbing every hop along the way between me and the IT Pro TV website? That saves me from having to go and ping each one. Now, I mentioned not everybody has traceroute anymore. Largely, that has been replaced by tracepath. So if you don't have traceroute, you probably have tracepath. And when you run it, it basically does the same thing, except it leverages some of the newer Linux APIs to be more efficient in the way that it works. So it's going to go out and it's basically showing me who it can actually get to and resolving that so I can find out where my network breaks down. I've got a couple of no replies. Those no replies probably indicate that I'm hitting a firewall. We have a web application firewall that's likely hitting, and that's where it's stopping. But that's a great thing for me to see. I can see that happening right here and determine whether or not that's causing my problem.
But Don, where do we go if the problem is on our end?
All right, so if the problem is on our end, right, maybe I can't ping my physical adapter, I can't ping hosts on my network, right? So it's all right here in-house. Well, in those scenarios, a lot of times we need to take a look at our network configuration. And it could just be that our network needs to be reset. It can happen, right? The drivers that power network adapters sometimes crash or have issues. Sometimes in Linux, they have to reverse engineer things. They don't work perfect. So we just need a reset, okay? If you're on a sysvinit system, resetting is not that hard. You can jump in and get to your services and so on, but we probably need to evaluate whether or not we need to reset in the first place. So I need to just look at my configuration and find out, does it match what I expect? So I showed you already the IP-addr command, so I can see my IP addressing. Do the addresses match what I expect to see? Does it look like I'm in the wrong subnet? Am I supposed to be in the 10.0/16 subnet? If I see a difference there, that might indicate I need to go and change my configuration. All right. We can also do IP link, which is a very similar command, basically showing those interfaces and their MAC addresses. One question I get, actually kind of stemming from our previous episode, the old ifconfig command, it shows a lot of other things like interface errors in case you're having hardware interface errors. And IP-addr doesn't show that, right? Or IP link doesn't show that either. So what happened to those stats? Those are kind of nice to have. Well, they are still there and we can still see them. What you need to do is run IP-S link. And that says show me the statistics of the link. And now I can look and see, am I getting interface errors? And so right here I can see my interface errors if I'm having them. Now that's a great indicator of a hardware problem. It could be a bad cable. It could be the cable terminator, RJ45 plug that's on the end of the cable is maybe not crimped right. Could be a loose jack. We see laptops, they get damaged jacks all the time. It can be any number of things like that. That would be a physical issue on our device. So we'd need to do a warranty repair or I don't know, whatever mechanism it is we use to replace that. Easy way to test there is to get like a USB network adapter and just kind of throw it on there as an extra one and test that out. And if that works, then you know there's something wrong with your onboard adapter. So that's one way to go about it. If you're on a virtual machine and it's a virtual adapter, the odds of you having hardware errors is really low. But it could be the underlying hardware actually is experiencing a problem. So you'd see that kind of pop up a little bit here. You'd probably need to troubleshoot your host, not your virtual machine in those scenarios. But this is a great way to see that. You can also do IP route to look at your routing table. What router are you using? Who's your default gateway? Right now mine is 10.0.0.1. Funny, because earlier I said 10.0.0.2. I see I'm using a different default gateway. Is that a problem? Maybe, right? Or maybe not. Maybe that's fine. I'm just getting routed over one way or another. So these are all things that we need to pay attention to evaluate, is our network configuration correct?
What if our settings don't match the running configuration though?
So if they don't match, right? If we've got our settings the way that we want them and they don't match what we see with these commands that I just showed you guys, then it's time to reset. I mentioned resetting the network. Now, resetting is going to vary depending on your system. So if you're on an older sysvinit system, then it's actually kind of easy. You just say sudo service network restart. Like that, and that'll restart the networking stack, it'll reload the configuration, everything should go back to nice and neat. However, most systems run systemd these days. That command is not going to work. So instead we need to do something a little bit different. We need to say sudo systemctl restart Network Manager. And the N and the M in Network Manager are both capitalized. It's case sensitive. And that's going to reload that network stack, reload the configuration files, and get everything kind of refreshed and save you from a reboot. Now, I'll be honest with you, there are plenty of systems that don't even use the Network Manager, that use NetPlan or whatever. And in those scenarios, sometimes it's just easier to reboot, right? When you restart your networking stack, you're going to disrupt your users. So restarting the network stack versus rebooting is kind of the same impact. It's just the duration. Well, if you're dealing with like Linux virtual machines and Amazon Web Services, they'll reboot in 5-10 seconds, pretty fast. Restarting the network stack is usually like 1 second, so it's a lot faster. But if you can tolerate that small of amount of downtime, then you can probably just reboot the system and be done. So that's kind of the guaranteed way to make sure that we're loading all of our configuration files.
Can we see if traffic is actually coming in and out?
Yeah, and we might need to, right? I mentioned earlier, what if I have a unidirectional connection on a switch? It happens, right? There could be damaged cables. It actually happens with fiber a lot more than it does with copper because, fiber, you've got these light beams that are being shot down these glass tubes that, well, not really tubes or wires, whatever, but it can get disrupted. So you can end up where you can only transmit or you can only receive. And that typically shows up in your statistics. So like when I do IP-S link, and you look in here at your receive bytes versus your transmit bytes, if one of them is 0 and the other one is going up, that lets you know you've got unidirectional communication. We can also actually look at the true traffic that's moving across our interface. And there's a few different ways to do that. One way I like to do it is I just want to see the fact that there is data, that there is a connection or whatever. We used to use the netstat command for that, the network statistics. That command has also been replaced with SS, which is the socket statistics command. And just like all the other ones, it was rewritten to take advantage of the newer Linux kernel APIs. Fortunately, netstat and SS use the exact same command line arguments. So if you know one, you know the other, it's just a different command. So for example, if I want to see all sessions, all active TCP sessions on my computer, I could say SS-ATP. All right. And if I just run it, it'll work. But as a user, I only see so much information. If I sudo that, I'll see a little bit more. So I'm going to go ahead and sudo mine and run ss-atp. So here are the active TCP connections. I can see that I'm listening. I've got SSH, the Internet Printing Protocol is running. We've got a few SSH sessions that are active right now. That's me connecting into things. I've got a web server open, HTTP. So I can get an idea of what my system is doing on the network by looking at this. If I drop the A off and I just do SS-TP, then that's going to show me the TCP communications that are actively moving data right now. And I can see my SSH sessions are doing that versus like IPP, the Internet Printing Protocol, was just sitting there waiting for connections. See, it's got a listen over here on the left side, but these SSH connections are actually established. They're moving data. That's my connection to my Ubuntu server and my Red Hat server here in the background. That's what those are. So I can see that that's going on and I know it's happening, which is a pretty useful thing. I can also do, this is kind of one of my favorites, ss-program. This command doesn't always work. But what it tries to do is it tries to show me exactly which programs are leveraging. Oh, actually, it might not be supported on this system. It tries to show you exactly which programs are using the ports that are open. Now, I really already saw that when I looked up here. I could see that it was SSH or whatever the processor was. Here it's Apache 2, SSHD, CupsD, I can see it. On some systems, you are able to run -- program, and it tries to give you the full path to those. So it's not supported on this one that I'm on, so I can't do that one. Let's see, what else do we have on SS? I think that's really about it. There's a few other things, like you can view the routing table with SS. Actually, apparently not here either. So we can view a few other things with it, but I typically use other commands for that. IP route is a much easier way to see our routing table and get that information. But if you want to see the actual raw data that's moving across a network interface, there's another neat command that's really useful for that, and that's the TCP dump utility. TCP dump has been around a long time. It's installed by default on the majority of Linux distros, and it lets you see that traffic. Now, when you go to view traffic with TCP dump, it can be overwhelming. It grabs a lot of information. So what I normally do with it is I run TCP dump, and hang on, let me see what my adapter is called, ENS33. So I'll say sudo TCP dump, and then I'll give it an interface, -i, and then I'll tell it ENS33. That's my interface that I want to watch. And then instead of throwing it on the screen, I'm going to drop that into a file. Now, so I'll just call this my, I don't know, network data. And it's just a text file. But if you actually call it .pcap, programs like Wireshark can open this up and interpret it and show you all sorts of great data in a GUI. But I'll just call mine .txt for right now. I'll make it a text file. So it's now running, and it's collecting network data. So when I'm connected to these SSH servers and I'm doing whatever, that's SSH traffic that's being generated, and it's going to be getting captured by this other adapter. So it's kind of recording that that's happening. And when I'm done, I can break out of that, and I see that it caught 4,387 packets. Actually, it caught 4,291, so it dropped a few for some reason. There was a filter on it. And if I take a look at that file, now I can scroll through and see everything that happened during that brief period of time. And you'll see there's quite a lot in here. And if I feed this into Wireshark, it'll actually map out all of these communications. I can see who's talking to what and what type of activity is happening. That can be really useful, especially on remote servers where you don't have access to the network. If I've got something running in AWS, Amazon's not going to let me do a mirror port on one of their switches. That's all hidden from me. But TCP dump will show me quite a bit.
Well, is there anything we can do if we think of firewalls blocking us?
That is actually one of the leading causes of network issues. So you might think, oh, I can't get to the internet, but it turns out there's just a firewall that's stopping you from getting to one server. An end user, they always take it to the biggest scale, right? If they can't print to their printer, the whole network must be down. That's just what happens. So if you think there's a firewall stopping you, you might not be able to ping the server because pings are being blocked. Right? So, for example, I wonder if I can find somebody real quick that blocks pings. Does CNN? No, they're allowing it. Shoot. You'll encounter this sometimes with web servers where they block pings. They just don't want people pinging them. I'm sure there's somebody great like Yahoo or somebody who doesn't allow it. But if you find somebody where you can't ping them, how do you know whether you can connect or not? Well, ping is normally what we would use. But we could connect on whatever port that service supports, right? So let's just pretend for a moment that CNN wasn't allowing me to ping them. So when I try to ping www.cnn.com, I get that it's not connecting. Well, they're a web server. So it makes sense that I would have to be able to connect to them on port 80 to be able to get to the web page. So can I connect on port 80? Well, if I'm firing up a web browser and I can't, maybe it's a problem with the web browser. Maybe it's got proxy settings or something. Well, there's a command line utility called netcat. And what netcat lets me do is connect on any network port and see the output, right? Like the cat command from the command line where it cats a file and it shows me a file's data. Netcat shows me the network's data. And so I can point it at any server and see what's out there. I could say NC and then point to www.cnn.com. And then I'll just add 80 to the end because I want to connect on port 80. If it's using SSL, which every site is these days, then I would do 443, but it's going to be encrypted, right? So I'm going to see a whole different set of data. But when I try and connect, if I get through, then yes, I'm able to connect to that server on port 80. If I'm not able to get through, then it breaks. Now, with HTTP, it's expecting me to issue a command, and the command that we usually issue is the get command. And, apparently it's not going to get the index. So let me try that again. I'll get index.html. Well, there we go. At least I got a bad request. So I got a bad request that didn't find index.html, but that's okay because I got this message back. That's that server talking to me. It just told me, hey, Don, I can't help you, right? And so I know that I did actually connect on port 80 to that system. In the past, I used to use Telnet to do this. Telnet could show some, but Netcat will show just about anything. So you can connect up and get some really good information from systems. And it's a great way to test if you can connect on a specific port. So the firewall might be blocking pings, but now I can get through with this protocol and at least see that I'm able to get there.
Awesome. Troubleshooting network connectivity in Linux brought to you by the one and only Don Pizzette. Before we move on, anything else you'd like to say?
I just covered the topics that show up on the exam, the main troubleshooting tools,
Right.
but there's a ton more. I mentioned Wireshark. That's not on the exam, but in real life, super useful utility. So when it comes to network connectivity in real life, don't hesitate. Use any tool you can get your hands on, right? And there's plenty of them that are out there. Just be aware, like you saw here in this episode, sometimes the tools vary from distro to distro. So don't expect every tool you're used to be present. You might have to improvise.
Oh, awesome. And there's a lot more in LPIC 2. You know that, so make sure you watch every episode. Thanks again, Don. Thank you. We'll see you again soon. Bye-bye now.
Thank you for watching IT Pro TV.
DNS servers not working properly? Well, let's talk about how to troubleshoot that right now.
You're watching IT Pro TV.
Hello, welcome back to LPIC 2. I am Zach, and this is Don. Hello, Don.
Hello, Zach.
That's our official beginning.
Very formal.
Okay, so DNS servers,
Sure.
troubleshooting, and where are we at with all that?
All right. Well, we already talked about DNS servers in the network configuration episode, but now we're going to talk a little bit about troubleshooting them, because when DNS breaks, well, it pretty much ruins our whole network connectivity. So we need to learn how to troubleshoot it and learn some of the tools we can use to identify whether or not DNS is the root cause of issues that we're having. So that's what we're going to see right here in this episode.
Well, what are some of the symptoms we may see when name resolution is not working properly?
There's a number of different things that can happen. The most common thing, what people see right away, is their web browser stops working, right? Because in your web browser, you type in address names, not IPs. That name lookup fails, and you don't get to the addresses. So that's usually the number one thing that people spot when a DNS server isn't working. But there's plenty of other things that can go wrong too. For example, if your system is set up to use network time protocol and it's syncing against a network clock, your clock may be wrong because it's not able to do a name lookup and connect. If you have VPN connections in place, or even SSH that's doing certificate-based authentication, that can break if your DNS servers aren't correct. Automatic updates. If you're doing system updates, those typically rely on DNS names also. So there's a ton of underlying infrastructure that starts to break down when you're not able to properly do DNS lookups.
So where would you start troubleshooting if you suspect DNS might be the issue?
So there's a few things we can do. Obviously, our configuration could be wrong, right? If our network configuration is wrong, or we're pointing to the wrong DNS servers, then that can be a problem. But that's not something that just pops up all of a sudden, right? If I manually edit a file like resolve.conf and I set my DNS servers, that's not just going to magically change tomorrow. So it's pretty unlikely, but double check your configuration file. It's a good idea to look. On a Red Hat system, that might be buried away in /etc/sysconfig/network. On a Debian system, it might be in /etc/network/interfaces. If you're using a really old system, it might be in /etc/resolve.conf. That was where DNS servers used to be set. Or you might have systemd resolved that's setting your DNS servers, or you might have the network manager or NetPlan or all these different places where your DNS servers may be set. We've kind of talked about them previously. So you'll want to double check a lot of those. One place that something can pop up is your hosts file, and I don't think we've talked about that one yet. So on your system, there's a host file that can override DNS, and it can point to bad things. I use it pretty frequently for testing. When I've got a production and a staging server, I might choose to redirect a domain name to point to a staging server instead. Let me show you that real quick here on my Ubuntu box. I'm going to jump into /etc, and if I take a look at /etc/hosts, that's a file that was created for me. Right? Now, I've added some records to it because I use this quite a bit, but the main records you should see in there are your loopbacks. And so I've got a loopback for localhost and a loopback for Don's laptop. Those are both pointing to 127.0.0.1. But I've added an entry for Ubuntu and for Red Hat. Those point to my little virtual machines that run in the background. So if I want to SSH into my Ubuntu system, I can do that by a name. Well, I could put something in here that was wrong. I could point that www.microsoft.com points to 127.0.0.1. If I do that, can I get to Microsoft.com? No, because it's going to come back to me. It's going to break things. So if somebody's pulling a prank, or we pushed up a bad update, or you get malware on your system, a lot of hackers will use overrides inside of the host file to be able to kind of push you to systems that you shouldn't be going to as part of the way that they gain a foothold in your system. So these are things that you'll want to evaluate. Take a look at those configuration files. Make sure they're still set the way that they should be set. Again, unlikely, but it is one of the things that could happen that could cause a problem.
So let's assume our settings are correct.
Okay.
Because why not?
Yeah, they likely are.
Where do we go from there?
All right, so from there is where we get to the real meat and potatoes of this episode. We need to be able to troubleshoot what's going on with DNS. And there's a couple of utilities that are built into almost every Linux distro that we can use to be able to figure this out. All right, so let me run through a few of these. The one that's kind of the most venerable, that's been around a long time, but is very common in other operating systems as well, is NSLookup. That's the name server lookup utility. And you can run NSLookup to test a DNS lookup. So can I resolve ITPro TV? So I'll look for www.itpro.tv. And when I run that, it reaches out to a DNS server and I get an answer. I get an answer, here's the addresses, okay? If that doesn't work, I've got a problem. Okay, well, is the problem with whatever DNS server I used? Maybe. I can't even see what DNS server I used here because I've got systemd resolve D. So I just see a loopback. Well, maybe I want to try a specific server. I could say NSLookup, www.itpro.tv, and then afterwards I could manually point to a DNS server. I'm going to point to 4.2.2.1. And when I run that, it does the lookup and see how it didn't use systemd resolve D? Right? That's useful for troubleshooting. I'm now bypassing the name lookup system on my computer and going straight to the DNS server. Can I even reach that DNS server? Maybe there's something blocking me, but between here and there. But I connect and I get an answer. Did I get the same answer? Well, actually, that's kind of interesting. Look, I got a totally different answer. What the heck is that all about? Right? Well, all right, so the ITPro TV site, we have edge points that are all around the world. And so for whatever reason, it decided to route me to a different one. Now, that could be a problem. Maybe that's not supposed to happen. But more likely, I went from East Coast to West Coast servers. We'll have to see. But when you talk to different DNS servers, it's not uncommon to get different results. And so sure enough, Google is giving me one set of IPs, and what is now CenturyLink, I believe, owns 4221. They are giving me a different set. So those are things we need to evaluate. They're useful for troubleshooting to figure out. Now, I mentioned that NSLookup is kind of an older, venerable utility. It's present on most operating systems, even Windows, but it's not the oldest utility. That there is another utility called Dig. Dig is actually part of the Bind suite. Bind is the most common DNS server in the world. It's really what set the standard for DNS servers, and Dig is the utility used for troubleshooting with it. It works the same basic way. I would just say Dig and then specify a server or a name I wanted to look up. So I'll look up itpro.tv, and it goes and it does the resolution. Now, I like Dig better because it gives me the results in the standard bind configuration file format. If you're working with DNS servers, you've written configuration files in this format, and now I see that. And I get a little bit of extra information on it. Things like the priorities or weights that are set on some of these, or time to live values and other things, they all kind of show up in here, and you get an idea of how that configuration works. It is a little bit different if I want to override the server I do a lookup against. So again, that used resolve D. If I want to override it, I need to add @ and then the remote server I'm going to do a lookup against, like that. A little bit weird syntax. @ followed by the number of the server. And when I run that, now it's going to do the lookup against the server that I specified. So Dig has been around a lot longer, and it's always there on a Linux system. When you get to other OSs, it may or may not be there.
Well, oftentimes multiple DNS servers are involved. Is there any way that we can see that?
Yeah, and in fact, not often. Always. There's more than one DNS server involved. When you do a lookup, the very first thing it has to do is go up to the root hint servers and say, I'm looking for this TLD. I'm looking for .tv. And .tv, it sends it down to the next server, and you go there and you say, I'm looking for itpro.tv. And then it sends you down, you're looking for www.itpro.tv. So you'll bounce through several servers on your way, and that's all hidden from us, right? Those are all lookups in the background that we don't see. But if you're using Dig, it can actually show you that. And it's really cool. If you've never done it, I encourage you to. Here, I'll show you with itpro TV. I'm going to do Dig again. I'll just say dig itpro.tv or www.itpro.tv, like that. So that's what I'm looking for. And then at the end, I'm just going to add +trace. show me the full trace of this lookup. I want to see everything that happens that gets to the answer that I get, because a lot of weird stuff happens in the background of DNS lookups. So when I run that, now my screen is going to be a little bit different. And see how it kind of slow. Took it a little while, right? Because it's having to get a lot more information. Let me scroll back up to the top. There's a whole lot of mess in here. So right off the bat, right at the beginning, who am I talking to? The root hint servers. I'm reaching out to the root hint servers because I'm going to a .tv domain, so I've got to talk to one of them. And then one of them is pointing me to NSTLD, nameserver-top-level-domain.com, right? So that's where I'm starting to find out where .tv is. And then the next server I connect to was apparently a.rootservers.net, so I connected to the first one, and it's running DNS security, DNSSEC. So I see the digital signature that's tied to that server's record, so I can validate that these haven't been tampered with. That's a security mechanism. And then I can see I jump over to Amazon Web Services. We actually host the itpro.tv zone on AWS Route 53. So then we go over to Amazon, and Amazon is storing itpro.tv. And after talking with them and their digital signatures, then I get the response of www right here. And so I can see that www are these A records that are pointing to different IPs. So I get that information, and now I see every step along the way. So if I'm curious, if I think I'm being sent the wrong way, being sent to other servers or whatever, this shows me the entire query, all just by adding plus trace. And there's some interesting things that'll pop up when you start looking at other vendors and providers and things, that you'll find redirects and other stuff that happen where your name lookup can kind of bounce around a bit. But there's a lot of different stuff that's out there, and Dig shows it all. So really handy utility.
Well, is there anything else that might get in the way of name lookups?
Oh, there's a lot, right? So for the most part, as long as our configuration is correct, then it's usually going to be network connectivity that causes a name lookup failure. If I'm not able to get to a DNS server for some reason. So my solution there, use a different DNS server. If it's a local DNS server, that might be a problem. Maybe I need to use my local DNS server. But if I'm pointed at Google for DNS, maybe I switch over to CenturyLink or whoever, to provide that DNS service. That's kind of an easy way to work around that. But there's a lot of software that can get in the way, right? We've already mentioned ResolveD a few times in this series. So systemd ResolveD can cause some problems if we're not aware of how it handles things. The network manager is a great way to go in and manually set that name server to make sure we're using the right ones. We saw that in another episode as well. If you're on an older system that's actually using resolve.conf, there might be an order line in resolve.conf that's defining the order it does lookups. And it should say something like hosts, bind, nis, N-I-S. That's the old lookup order. Look at the host file first, then use the DNS servers, then use nis plus servers if you have them. Well, modern systems don't really use that, but if you've got an older system, you might need to look at that resolve.conf file and check that order to make sure it's right. Other things that can interfere, VPNs. Many VPN clients will override your DNS settings. While the VPN is up, they'll force DNS lookups over the VPN tunnel and make them go somewhere specific. So if you're using VPN technology, proxies, those things can override what DNS server you go to. And then lastly, DNS mask. If you're running a DNS server locally, like you might be running DNS mask, bind, or one of the various DNS servers that are out there, if you're doing that, that can cause problems because now you're not necessarily going to a server out on the internet, you're doing local lookups, and that server could be causing the problem. So all those things are things that we need to take into account when we troubleshoot name lookups.
Troubleshooting name resolution brought to you simply and easily by Don Pizzette. Thank you so much, sir. And before we move on, anything else you'd like to say?
It's a big topic. Name lookups are really critical to getting our networks up and going. Again, pay attention to your distros. Know that every distro is a little bit different. The main takeaway from this episode, though, I want you guys to remember NSLOOKUP and Dig, really handy commands. And with Dig, plus trace. Plus trace is awesome because you see everything.
Awesome stuff. And thank you again, Don. And keep this in mind when you're sitting in that well-lit room and you have that exam that you're going to be taking. And make sure you watch every episode of LPIC 2. You'll be glad you did. We will see you again very soon. Bye-bye.
Thank you for watching IT Pro TV.